Hello guys, welcome back. Today we are going to understand today Leetcode question that we have today 1870. So this is the question that we are going to understand today, right? So this is coming from the daily Leetcode question, right? So question is 1870 minimum speed to arrive on the time. So you are given a floating point number that is called R, and it is given here in the example. Okay, now it is saying that representing this R amount of time you have to reach to the office. To communicate to the office, you must take n trains in sequential order, or we have also given like a dist array, right? The dist array, right? Distance array, you can say, of length n, and where dist of I describe the distance in kilometer of the ith train, right? And each train can only depart at an integer hours, so you may need to wait in each train ride. So for example, the first train takes ride 1.5 hours. You must wait for an additional 0.5 hours before you can depart on the second train ride, right, at 2 hour mark, right? So it is given already. Okay, like it's in first train we have given, it is taking 1.5 hours, so you must wait for additional 0.5 hour so that you can depart the second train at a 2 hour mark. Okay, that we will see, understand the examples. Now we have to return the minimum positive integer speed in kilometer, right? And all the trains must travel at for you to reach the office on the time, and return -1 if it is not impossible, right? I think you got it, right? So what question is saying that we have given this is the, you can say, train you can say train ride, right? We have given in kilometer, and this is we have given the hours of the overall, you can say, train, right? Now what we have here, right? So there is, let's suppose n trains we have, and we need to take in order that ith train will ride for dist of I, right? Dist of I means this one. We are talking about this 0 to the n number of trains we have given, right? So we need to complete this journey, ride all these trains within r given time, right? So these are given time. So r is a decimal number representing the amount of time we have, and we need to return the minimum positive speed integer that is required, right? So one more constant we have, that is each train will depart at an integer hour, right? So if we completed the first ride, like let's suppose it is saying 2.4 hours, right? So what will happen? The first ride is completed at 2.4 hours, right? Then we can only start the riding the next train at third hour, right? This is the things he is saying. Means you have in the point, right? But you are not going to start after 2.5 2.4, right? You have to go after 3, right? So that's why it is saying that, like, our ride will complete, the first ride will complete at 2.4, right, hours, right? Means the next that train we are going to take, right, will complete at 3 hours, right? Third hour only. Okay, so one hint in the problem description is that answer will not exceed 10 to power 7, right? So the first naive approach we can apply to do an exhaustive search, right, over overall the, you can say, positive all possible positive speed, right? So we can iterate from 1 to 10 to power 7. Okay, and the first number that can lead us to complete the journey within hour, right, and will be that answer. But how we can find our some speed can make us complete journey within the constant time, right? So we can easily find the time required for individual ride for each train. Then the summing up, and we'll have some total required time, right? If the total time is less than hour, then it could be a possible answer, otherwise not. That's why you can see here we have given what list we have given, hours we have given. So give me 1 minute. Sorry. So at the speed 1, the first train take 1 by 1 hours, right? and since we already at an integer hour, we depart immediately at 1 hour. Okay, and that's why the second will start 3 by 1, right? So it is also again 3 hours, right? Similarly, the next will mark 4 hours, right? That is 2 by 1 hours, right? And if you calculate all these hour calculated, the first is getting 1 hour, then 3 hour, then 2 hour. 1 plus 3 plus 2, if you calculate, it comes 6, right? So total we have to mark 6 hour mark we have to take, means exactly the 6 hour we have given, and that we are completing, right? But how we can find out if the speed makes us complete the journey within the constant time, right? And that's why we are saying we can easily find the time required for individual ride for each train, and then summing them with the that we have given, right, to us, and the total time required. So that's why we can find this one, right? So if the total time is less than the given hour, right, this one, then it could be a possible answer, otherwise not. So this approach, right, we can observe is not efficient, right? We need to iterate over the whole search space and then iterate over every train to find total time. So can we reduce the search space, right? So that we can do only by, right, what, as you can see here, right, the binary search, correct? So as you can see, we have given distance, hours, right? How we'll do that? We are taking left and right. Right will take 10 to the power 7. Okay. So what we will take, I will take minimum speed. So while left is less than equal to right, okay, till that what I will do, left plus right by 2 is mid, right? And then time required will take a function, and distance will pass, and the given mid will pass, right? If it is less than equal to hours, right, because r, it should be less than equal to hours, time that required for the distance should always less than equal to the time given r, right? If that is the case, it means minimum speed is the mid, right? And the right will now mid minus 1, right? Let's suppose what I'm talking about, let's suppose this is the range, this is your left at 1 and this is at 10 to the power 7. Okay, in between that, if we are getting mid here currently, right, mid is what, left plus right by 2, this is your mid. If the time required, let's suppose some time some distance we have given and some mid we have given here, x is a midpoint, let's suppose. So this is your mid we have given. To complete this mid, right, we are taking less than equal to hours. Okay, if it is that case, means actually it is less than this hour, right? So minimum speed will become what, at here, right? Because this is the speed, this is the speed, and this is your kilometer distance, right? So distance and a speed we have given, so it will give you what, it will give you time, right? So how will find the time? Distance by speed is coming time, and that's why you will see here when we are calculating this one, then we will find like this only. Okay, that we will see later. Here calculating time, right? This time we are calculating here. How we'll calculate, that we'll see later, don't worry. Kilometer by, sorry. So minimum speed equal to mid we will do if this is the case, right? And then now this right is here and left was here. Now we will switch from here to here. So this search space is gone now, right? So now mid will become less than this one. Okay, so this is less than minus 1, means now right is here. Got it? So now the search space is this one only. Okay, if that is not the case, right, if it is not less than this, then we will find in here in this search space. Okay, so left will become what, here, and right will remain here only. Okay, like this, means search space we are reducing here. Okay, and if this will work like this, right, so you will get your minimum speed, right, similarly you have, and it will reduce automatically. Okay, on this one, I think you know the binary search, right? Now required time, right? So this required time how we'll find? So we are passing the distance and the speed, given speed, we'll take this time in point, now we'll start from I0 to the length, and for all the given distance we'll do what, distance at I by speed will get our time, right? So this is your time. Now how we'll find our time? So time will come what, time plus, and then we'll check if it is not the last value, right? If this is the last value, means we are doing what, round up, right? The selling value will take, otherwise we'll take that value. Like 2.4 will take, right? So for 2.4 it will take, for the first it will take 1.2, and like this. So if we'll come with the last, so how much time it will take? It will take 1 hour. Okay, so what will take? 2.4, 1.2, and there will be some value, right? So let's suppose it will come 4, right? Next will come 4.6, let's suppose. So we will in the last point, because we are taking this value, so it will come nearby 5. Okay, around selling value, and that's why we will return the time finally, because after selling, last value will update, right? So only the last value we have to do selling value, otherwise the rest value will do only the sum all the time, and this time will return as a here. Okay, I think you got it. Okay, if you have any doubt, please ping me in the comment box. Thank you for watching this video, guys. Thank you.